Okay, we'll get started. Welcome to those of you that are in the room and those that are online. My name is Isaiah Kiseka, and I'm a professor here at UC Davis. And it's a pleasure for me to welcome Robin Grimes. Robin is actually an alum of UC Davis in the Hydrologic Sciences program. And she's also the interim director of the OpenET Incorporation. OpenET is very fantastic service that Robin is going to share with you this afternoon. So without further ado, Robin, why don't you take it away?
Okay. Yeah, thank you so much for having me. You all in this room are probably more well-versed in some of the technical underpinnings to what I'm about to talk about today than I am. I was just commenting that I would love to take this class at some point. I do have a PhD in hydrology, but it was more focused on sort of multi-objective optimization. I was a JLEN student when I was here. So what I'm going to talk about today is more the applications focused side of satellite-driven evapotranspiration data. So why is it so important for water management? How are people using it across the Western US and even maybe beyond the Western US? I've got a couple of videos to show that I hope work, because it's really a lot cooler to hear from people who are actually using the data than for me to talk about how they're using the data. So yeah, thanks for the attention. Thanks for the opportunity to come and share this with you all. Definitely the stuff that you're learning in this class has some real, very big value out there in the real world in terms of water management. So it's not advancing. Let's see. There we go. So as you all are probably well aware, in terms of water management across the Western US, we're dealing with sort of ever increasing amounts of scarcity, droughts that are getting worse and longer in time and duration. And that's hard on anybody who's an end user of the natural resource that is water. For those of us who live in cities, we might be dealing with that in the sense that we have to take shorter showers at times when we're dealing with the drought. Tell our kids, in my case, I have 2 kids, to not take such a long time in the shower. For farmers who are growing the food that we eat, the food that we put on our table, they're dealing with even more severe challenges around this issue of drought and scarcity, right? They're trying to continue to produce the food that's necessary for a growing population, oftentimes with less water available to them, year after year. So what OpenET was built around was this concept that, look, we're asking folks at that field scale where decisions are being made and we're managing for water is getting more and more difficult to do more with less all the time. And we've been asking them to do that and asking the water managers that deal with managing systems where there's a heavy use of water in terms of irrigated use or in terms of forests and other natural vegetated landscapes. We're asking those folks to do this, to meet this challenge of scarcity and drought without really having an easy way to access information about one of the most important variables in a water budget, right? And I'm probably preaching to the choir with this class, but I have this slide here to say, OpenET was intended to make evapotranspiration data broadly available across the Western US, and we're actually starting to march eastward now at the field scale, wall to wall. So the map you see up there is showing field summaries, but the raster data, 30 by 30 meter pixel data, is also available on this website. We launched in 2021. Anybody can go to it. I don't know if you've had them look at it in the class at all, that's great. That's wonderful to hear. And to make it so that the data is available in a consistent way, so that folks who are managing water at the local scale, from the field to maybe a water district scale, all the way up through state and federal water managers and planners have access to the same information, so that, when you add the numbers up from the local management decision-making all the way up to that state level, things kind of match to some degree. People are using a common understanding of what's happening in terms of water use on the ground. Probably don't have to go through this slide. The main thing that I want to say here is that, this ET portion, right, evapotranspiration, that is really that portion of the water that once it's applied to a field or for some other purpose is gone, right, not available for reuse. And so when you're thinking about trying to manage for long-term goals in terms of what you're bringing a basin into balance, right, or managing for water sustainably, trying to do that without this understanding of ET, the analogy that we've drawn with OpenET is like trying to manage a budget without knowing how much money you're spending day to day, right? This really is that key variable in terms of understanding trends in water use over time. If somebody applies less water, if they increase their irrigation efficiency, does that necessarily equate to a reduction in consumptive water use? No, right? So there's this sort of, a lot of times people talk about increasing the efficiency of irrigation as a goal in terms of managing for drought and scarcity. In some cases, it can be a really good thing and it can be very helpful, but it's really important to understand concurrently whether or not consumptive water use, whether or not ET is actually going down. So because this is such an important variable and because OpenET, was meant to fill this data gap, this data wasn't available broadly in the way that it is now via OpenET. We sort of formed this project about 6 years ago now around these 3 goals, right? First being that we just wanted to make the data, put it out there, make sure that it was reliable, that the models and all of the information that went into making the data available was transparent, and that it was easily accessible. So not just available via some esoteric kind of spreadsheet somewhere that you might have to log into via a government housed system, but actually user-friendly, intuitive, easy to look at, easy to visualize, easy to use type availability, right? That was a really important aspect of this for us. Secondly, that we built trust in the validity of the data, because one of the things that the water management community was seeing before OpenET got built, and even still, I have to say we haven't fully solved for this challenge, but was that there are so many different methodologies, and I've heard that you've learned about them, for taking satellite inputs and weather data or weather station inputs and creating an estimate of ET, that there were oftentimes when, one party would use one consulting firm, another party would use a state model for doing this, the answer would be different. And instead of, marching towards solutions around the water management problems folks are trying to solve for, there was a lot of time wasted debating about whose number was right, and maybe litigation would be initiated. And, you waste a lot of time around that. So one of the things that OpenET has tried to do is to pull together the scientific community that is behind a lot of these approaches for estimating ET using satellite data and inputs, and bring them together on one team in order to help explain the differences in the numbers when those differences occur, and also to start to reduce those to the extent that that's possible, right? And provide an ensemble estimate. So hopefully you saw when you looked at the website online that you can do that, right? That you can look at each of the individual models, you can look at the spread amongst all the models, and you can look at an ensemble value that's supposed to represent the scientific community's sort of best guess for how to take the information from these multiple models and narrow it down to one number. And we believe that if we could build sort of that trust in the data and make it available, that sort of inherently just leads to goal number 3, right? Which is that a lot of innovative and locally driven water management practices that are really necessary for meeting the challenges that are out there are enabled at a scale that just wouldn't be possible if you don't have the data available at that kind of scale. So as I mentioned, one of the primary ways that we sought to build trust and sort of increase understanding in these data sources is to bring these different models onto the platform. So these are the ones that are there. Have they learned about every single one of these?
Not all.
Not all of them. Okay. Most of these models were chosen because they were already sort of marching towards operational use at a state entity or at a federal entity for one reason or another. And so they were all sort of already commonly adopted or largely adopted in one part of the United States. This is what the platform looks like. I might just kind of skip through here because it sounds like you guys have already had a chance to look. I'll make a point when I'm looking at this, these slides here. This is a field that is in Grand Valley, Colorado. And this is a place that in 2017, some of the growers there enrolled in a voluntary conservation program where they either completely shut off irrigation for a season or they deficit irrigated for a season. Does everybody know what deficit irrigate? Okay, great. So this is one of the fields that was enrolled in that program. And one of the things that these types of voluntary conservation programs tend to really have a hard time with is accounting, right? Accounting for the degree to which the changes in irrigation practice actually result in water savings or water conservation. Well, with OpenET, you very quickly get a sense in this time series image here that something happened in 2017, right? So there's the sort of like initial truth check, like, yes, water was not applied to this field as this grower or farmer said they were, they were doing in terms of participation in the program. And then even more sort of impactful is this particular visuals. You can look at the cumulative lines as well. So each of these lines represents a different year, right? And ET throughout the year. And at the end of the year, you can mouse over each of those dots there and see what the actual difference was in evapotranspiration from one year to the next, right? And this is the kind of thing that for these types of programs would have taken, thousands of dollars and months of time invested with a university partner or consulting firm to get to this answer, right? To get to this, how effective was this program, right? And you can add all these fields up and get to a sense program-wide what happened. There are some caveats here. This is evapotranspiration from all sources, right? So this is going to include precipitation, access to shallow groundwater, right? And so if you're wanting to do a real clear accounting of what changed in terms of the ET from applied water, there's some additional steps that need to be taken. But in terms of getting kind of a general sense of what happened here and how effective this is really transformative in terms of being able to do that right in just a minute, whereas it used to take a lot longer. So this is the part where there's some videos. And again, I hope they work for you all and for everybody online. Is somebody monitoring online in case folks can't hear or see? Okay, so let me know if people are saying they can't hear it. So I kind of mentioned this already in the screenshots from the platform, right? That rural communities can use and are using OpenET to design locally driven water conservation and trading programs. And this is a rancher that I'm going to play this video from here. He and other ranchers in Colorado are doing just that. And they're looking not only at the water savings that are achieved by different deficit irrigation or full stop irrigation practices, but also then looking at recovery. How are those ranches recovering in the next season? What are the implications in terms of cost to me as a rancher? And trying to get to that final answer. What's the most cost-effective way for us as this, this community right here to meet our water conservation goals? So I'll play this video briefly. No.
Okay, I'm a rancher just outside of Creighton, Colorado. We run a cow-calf operation, raise hay, irrigate out of 3 different water resources. We also operate a guided fly fishing business to help supplement income and work the ranch as a family. Water to our operation means everything. Through the drought of the early 2000s in the headwaters, learned some lessons there, which is largely why my family and my neighbors are as engaged as we are with water. We are truth testing different forms of measuring water used for irrigation on high altitude perennials. We are studying the recovery of those crops after having different forms of treatment to them, the full season curtailment, and then a split season where the producer was allowed to irrigate until June 15th and then required to shut off for the remainder of the season. I'm excited to continue to learn about the information and data gathered by OpenET. I'm excited to truth test that against many of the other forms and mechanisms that we have working. OpenET, it completely changes our ability to understand what's going on within our fields. Water is the lifeblood of the West, and we have to figure out how to do more for the same with less. The more that we have the science and the data, the more that we'll be able to make good decisions.
Do that twice. So that's from the perspective of somebody, where their community kind of came together, partnered with some NGOs, actually Nature Conservancy is another partner on that project, and some local universities, and they're all sort of working together and with OpenET on this multi-year study to get to that answer for that community. You can imagine that, for example, in California, there's folks who are wanting to incentivize these types of programs even when they are, initiated at that very local scale necessarily. So for example, groundwater sustainability agencies in California, they're developing allocation schemes right now. Some of them are thinking about maybe trading, water trading as an option for growers. So for those folks that are thinking about this at that sort of scale, at that system scale, at the local still, but multiple producers, multiple growers, multiple landowners involved, this is also really helpful for them, right? Because again, you can take that accounting that's happening at that field level, or at the ranch level, add it all up and start to account for a budget, start to track and manage a budget at bigger scales as well. And if we kind of keep scaling out here, the next application that we've seen that we've been really excited about is use by state level policymakers, right? In helping with planning for the future. So looking at something like the California Water Plan, but also, as I alluded to earlier, in working better together with local communities, in some cases, even reducing the burden of regulatory compliance, because everybody is sort of agreed to use a similar data source or is able to use the same data source. So there's an example that's just happened in the California Delta, where there was an alternative plan of compliance agreed to by both the Delta Water Master, which is somebody who works for the state board, and then also landowners and communities within the Delta, where they're using data from OpenET to report on their water diversions, which is a state law requirement that they have, rather than having to put siphons or meters on all of the siphons going onto and off of those islands in the Delta. So it's a huge cost savings for them, and it's a time savings as well. And I'll let a couple folks from the Delta, both the former water master and then also a grower pear farmer in the Delta, talk a little bit about this particular application.
Been farming piece of dirt since the 1850s. We are proud stewards of this land. As a farmer by nature, you're an environmentalist. Your well-being is tied to the well-being of the plants and wildlife that depend on the same resources that you do. The Delta, 750,000 acres, roughly the size of the state of Rhode Island. Largest estuary on the coast of the North and South Hemisphere. The last major drought, it became abundantly clear that we didn't have sufficient data to make critical decisions about how to manage in shortage circumstances. So a piece of legislation passed that basically said every diversion of more than 10 acre-feet per annum needs to have a measurement device attached to it, let's say a water meter. Almost immediately it became clear that we were facing challenges that we had not anticipated. Measuring water in the Delta has been a fool's errand. Measuring just the applied water or diverted water doesn't give you the full picture. Instead of putting a meter on every diversion, and there are 2,500 to 3,000 discrete diversions in the Delta, it just made sense to look at something that was less invasive, less expensive. So OpenET is the game changer for the Delta because it will give us real-time information that has a high degree of credibility. OpenET, it gives us a bird's eye view of what's actually going on the ground in real time. It provides an opportunity to get more relevant data. There will be ways to use this information going forward that will benefit everybody, not just in the state of California, but I believe throughout the Western United States and beyond.
Probably a couple caveats I should make about that particular use case. One of which is that the Delta is a really unique place, right? Is this class generally fairly familiar with the Delta? Okay. You know, the Delta is a series of sunken, they're not really islands, right? They're sunken beneath sea level, farmed tracts, right? And so water that is applied within the Delta and not then used consumptively through evapotranspiration tends to be pretty readily and almost immediately available again in the channel, right? So that difference that can happen between what is diverted and applied and ET in terms of complying with this regulation on reporting on diversions is not so important from an accounting standpoint. It is really important in terms of a pollution standpoint, right? So in terms of water quality, if you're thinking about if a lot more water is applied and then a lot of that water then runs back into the channel and there's pollutants in that water, that's something that the state board also needs to care about and track, but that's not, you know, what they're doing with this particular application. So I just wanted to mention that. I think in a lot of cases, when you're talking about getting a better sense for managing a budget and managing for water sustainability, you kind of need both pieces of information, right? You need to understand the amount of water that's been applied, and you also need to understand the amount of water that's been consumptively used. And that's especially true, again, back to this groundwater sustainability agency's use case, right? They're needing to understand if there's a lot more water being applied than evapotranspired, then of course there's this sort of question about recharge, right? And how much of that recharge is sort of shallow and available, how much of it is going deep. So just looking at one of those data sources versus both, I think in a lot of places is not enough. So anyway, a little bit of a uniqueness to that particular application. But the thing that I don't think is unique about it is that it's helped bring the state board and local communities within the Delta together around this data source that they both can trust, that they both use, and that works both at that sort of field scale and also kind of more broadly if you're looking at the picture across the Delta. So finally, there's this last use case here, which is that farmers are using data, like they've been using ET data for a long time. They're starting to test and use OpenET specifically for irrigation practices to help maximize crop per drop, reduce costs for fertilizer, water, and energy. And one of the groups that's testing the use of OpenET for that purpose is Gallo here in California. So I'll show a quick video of that. And this is the last video. They can't see this or they can't see me. Oh, okay. It's okay. I'll turn it back on. Okay. Hi. Okay, so here's this video of Gallo's application.
One of the Gallo vineyards in Sonoma Valley. This is about 300 acres of wine grape. This year, we found already 3 episodes of heat spikes with the reservoirs emptier than they were before because of the drought. So we have a certain amount of water to go through the system. That is where adjusting irrigation as much as possible to the water needs and not wasting a single drop is going to help us. ET is the real amount of water that is being used by the vineyard. So the ET data in some cases will help us detect over irrigations and therefore will end up with significant water savings. In other cases, it's going to help us to distribute better that water at every moment in the season.
There's also been scientists with NRCS has built a Excel version of an irrigation scheduling tool that pulls in data from OpenET. So we're excited to see that tested and hopefully start getting used across the West as well. So as I mentioned, the platform was launched in October of 2021. Those videos that I showed, those were use case partners that we've been working with prior to launch, right? So what we wanted to be sure, again, as part of this sort of trust building and catalyzing use of this tool for more sustainable water management, one of the things that we knew we needed to do was sort of tell stories about how it gets used and sort of give people examples that might generate some more ideas in other communities. So we worked with many use case partners. Those were a sampling of the ones that we've worked with to do that. Since the platform is launched, we've seen some other applications crop up, and I'll just sort of speak to a few of the ones that we're most excited and proud of. This is in the Upper Colorado River Basin. The Upper Colorado River Commission voted recently, I think it was last year sometime, to adopt the use of one of the models, the EE metric model, from the OpenET platform for measurement of consumptive use across the Upper Basin and the Colorado Basin. And that was a really huge step forward from the methodologies that were used in the past, none of which were these satellite-driven methodologies. They all were the sort of crop coefficient reliant methodologies where you weren't getting the nuances of the differences in ET across homogeneous crop type, right? So this is a big advancement. Just adoption of a satellite-based ET approach is a really big step for them. And we're excited that they wanted to use one of the models that's available through OpenET. So that was a great one. Another thing that we're seeing is some use of the data in land repurposing type programs. So there was a big grant application that went into USDA for that was a partnership between Bridgestone and several universities. They're listed here, some tribes, I think. And the concept here is that Bridgestone is looking to diversify their supply chain for rubber for a host of purposes. But one of the sort of benefits that they're looking into better understanding around the diversification of their supply chain is if we switch to a different rubber source, are there climate change related or climate related benefits to that? And the two that they're looking into is carbon capture and reduced water use. So in Arizona, there's a group of farmers that are getting paid to switch from things like alfalfa to wayuli, which is this alternative rubber crop. And OpenET is being utilized as the sort of accounting tool to help them understand the water savings from that particular investment. There's a host of other things that are being studied. It's a really cool project. OpenET just has kind of a small part of it, but still a really neat one to see. We're also seeing use of the tool in Oregon. After California decided that they also needed to develop budgets for all of the groundwater basins across their state. So there was a law that passed that required that. OpenET data is now being developed. We're actually producing data back 30 years for the state of Oregon to help them in their development of the groundwater budgets for all the basins across their state. It was also incorporated into a conservation reserve enhancement program application, which incorporates some land repurposing aspects as well, some sort of paid deficit irrigation, and maybe even a little bit of fallowing. I haven't looked into the details of that program. But again, OpenET is being used as a tool for understanding the water conservation outcomes of those different investments that are made towards that particular goal. Let me see, do I have time to show one more?
Yeah.
So one more type of application that I haven't spoken to at all, but that we're starting to see some growing interest in as well. And I think there's some sort of fundamental research and science in a lot of this, but in this topic that could be really fascinating to engage in, which is this like concept of, can we use this data to, both predict sort of fire severity, which is something that this video does not speak to, by looking at the health of forests and using ET as an indicator of the health and dryness of forests in different parts of a watershed. But the way that that's being used in this particular application is folks are asking, can we use this data to help us understand how the inputs into our reservoirs may change from forest mitigation practices? So if we thin our forests, the trees aren't taking up as much water as ET, does that then result in additional flows into the reservoirs that, feed into our system? And so there's some research being done by the Salt River Project, which manages a few watersheds in Arizona, and I'll just let LD Barton speak to this application.
Clear Creek watershed. This is one of our most at-risk watersheds because our dam here is completely surrounded by ponderosa pine forests that are in an unhealthy state. With increasing temperatures, we're having increasing variability of droughts, and unhealthy forest has fuel for large catastrophic wildfires. So we adopted a 2035 goal to support 500,000 acres of forest thinning. Now, this is unprecedented since no utility in the United States has taken on a forest health goal. It's going to take a lot of science and tech and data. And so when we begin our forest thinning projects, the trees will become more drought tolerant. OpenET will help us have data to inform how our forest thinning projects are reacting to those climate change impacts that we're seeing today.
So similar to she didn't really speak to it in the video, it wasn't really clear from the video, but similar to that use case in Colorado that I showed with the rancher, they're also looking to understand recovery, right? And they're looking at ET data as a way to help them see how quickly the forest after a thinning project has been implemented sort of comes back, right? So that's another aspect of that program. I showed this slide because I think you all probably, again, understand a lot of the inner workings of this really well. I wanted to focus on the right-hand side, which I guess you all can't see. Sorry. Here, and just say that you all may have seen the data via the website. Have you, I don't think you were able to show them probably the application programming interface. No. So we also built an application programming interface, and the reason for that is that that's, how many are familiar with what that is? A few. So it's a way basically for a software system to talk to another and pull data from one system into another in an operational and automated way, right? So that you don't have to each time go back and say, I need the data for these fields, you know, for this length of time and this time series, give it to me over here. I don't know if that was maybe you could articulate it better than I could, but that's my best take at trying to articulate it. And so an application programming interface is really important if you're wanting data to be able to be incorporated into other decision support systems or into other models, right? So that was something that the team definitely put a lot of time and energy into making sure that that tool was available as well. And we're seeing the benefits of that in the sense that consulting firms that are working with GSAs in California are using the API to pull the data into their models and into their accounting systems. The data from the API is being used by researchers, for example, so that they can pull large swaths of data to, you know, to look at trends in ET over time and big watersheds and things like that. So equally important to the user interface that you guys have seen is the website is this API in terms of making sure the data can be combined with other really important sources of information for water management in tools. Irrigation scheduling tools are another great example, right? That's how those tools incorporate the data from OpenET into their systems, is using that API interface. So the final thing I wanted to just speak to is this question of accuracy, right? One of the main issues I think with trust with any satellite-driven data source is how in the world are you measuring what's happening on my field right here using something that's flying so far overhead, right? And so I think one of the things that is going to be an emerging area of ongoing research actually is understanding the way that these models perform given certain land cover types, given certain circumstances. The team, of course, did their best to answer this question of how accurate, how reliable are these models. But, you know, with the time that we had from outset of the project to launch, they were able to do that at the scale of the United States, right? So they were looking at ecovariance towers across the whole US. They did a really big effort in QA/QCing those towers and making sure that the data that they were incorporating as sort of true, you know, land, you know, on the ground estimates of ET was actually high quality data that could be trusted. We talked about energy balance closure or anything like that with this class. Yeah. So they went through an effort to see, you know, can you close the energy balance at these towers? How far off are they, et cetera? And so some were weeded out, right? And then there was a remaining 142 towers across the whole United States that were used for this initial intercomparison effort. As you can imagine, of 142 towers, there may be 3 that are shrublands, right? Or there may be 2 that are almonds, right? You don't end up getting a very large amount of coverage over any particular land cover type with that amount of ground-based towers. But nevertheless, it was a lot of data, and they were able to look at, you know, on an average, how are these models performing for crops versus forests versus shrublands and things like that. So the table that I have up here is the results that they got for croplands as a general category. And you can see that for water year and growing season, that's a pretty reasonable, you know, I think pretty impressive result that you're getting, you know, below 13% in terms of mean absolute error. Of course, the errors start to increase as you start getting shorter time steps. So when you go to monthly, we're looking at about 17% mean absolute error, and then daily is higher at 23.5%. I think, you know, the important point here is, what is the comparison, right? Like, what other data source can you use, and can it be much better? And being really clear-eyed about, like, what is the accuracy of the alternative is a really important part of the discussion. As I mentioned or alluded to earlier, though, there's a lot of work still to do on this topic and understanding this better, and I think on improving the models. As an example, pretty early on after we released the data, we got a huge barrage of input on whether or not it was working right, which, you know, at first was a little bit overwhelming in that a lot of that input was negative, right? Like, this doesn't look right for my field, et cetera, et cetera. But actually, I think it's already served to advance the science a bit, because one of the things that became clear from some of the early input that we were getting from growers in the Southern San Joaquin Valley, for example, was that it didn't look quite right for mature orchards. And one of the modeling teams was looking at that, and they thought, well, you know, the satellite passes over around 10 a.m. maybe there's some shading in the inner row that's causing some problems in terms of the land surface temperature for mature orchards. Can we implement some kind of, fix to the model to help account for that? And so they've done that. Now the model for that was the EE metric team that implemented that. Now that model is measuring ET a bit lower for mature orchards than it was before. Work to do to find out if that was, how much better things have gotten because of that particular shift. But it was because of that dialogue, right? It's because the data's out there and people are providing feedback. People are scrutinizing it at a scale that it just wouldn't have been able to be scrutinized at before. And that dialogue is getting directly back to the scientists who developed the models, that we're starting to see those kinds of things tested, I think, at a much quicker pace than would have otherwise been possible. And so that's exciting for me in terms of kind of playing out the value of doing this thing and getting this out there. So, because water management is local, though, I think one of the next steps for OpenET is conducting comparisons like that was conducted at the scale of the entire country at more local scales. So trying to get our hands on more tower data, lysimeter data, if and wherever is available, and ask that question of, how do the models perform for the San Joaquin Valley, for the Sacramento Valley, for California, right? Can we improve them for those particular places? And can we improve the ensemble value? So there's that question of, can you improve the underlying approach? Or maybe maybe two of the models actually do really well for this particular crop type or for this particular set of circumstances, and we just throw the rest out when we're calculating the ensemble in that type of, for that set of circumstances. Whatever is decided and whatever research is done around all of this, one of the reasons we call it open ET is, one, because the data is open, but also because we are really transparent and open about all of the research that goes into it. So the methodologies for the models are available on the website. All of the information about the accuracy of the models is available on the website. As we learn, as we conduct additional assessments, we will try at the best pace possible to continue to update that site and make it available for everybody to see and to learn from as a scientific community. So that is one of the sort of missions and goals of the nonprofit. I should have mentioned that from the beginning. OpenET started as a massive project. I probably should have paid more homage in this talk to all of the groups that were involved. It was an effort that included NASA, scientists from Cal State University, Monterey Bay, scientists from a bunch of different universities outside of California, USGS, USDA, and others. EDF's role was just in kind of management of the effort and coordination of the effort, and in stakeholder outreach and the development of these use cases that I shared with you all today. And since we also launched a nonprofit, and the nonprofit's goal is to sustain production and public availability of this data for purposes of improved water management, and to support, ongoing advancement in the science, and support use cases that might not otherwise, get funding or support via typical sort of public sources of funding or private sources of funding. So there's the goals for the nonprofit. And I think that the full list of partners is at the bottom there, and maybe I'll stop there and make sure there's some time for questions and discussion.
Please join me in thanking Robin. Any questions in the room or online?
Yeah, you started to talk about this at the end a little bit, but can you speak a little more to is it a nonprofit? Is it a multi university coalition? Like what's the model behind how you designed it, and why did you choose that specific way of running it like that?
Yeah, I would say yes, and so I think we have established a nonprofit, and the nonprofit is part of a consortium, right? So those partners at those different universities and at those federal institutions, we're all still coordinating, we're all still working together. In some ways, the nonprofit is serving as a fiscal sponsor for some of those outside institutions that are a part of the consortium. In some ways, I think there's some things that the nonprofit's brand new, right? So we're just sort of building this out. But my vision for it is that the nonprofit will hold some pieces of it, like making sure that use cases and end users who, again, would have a tough time kind of finding support from other entities, have a place where they can get support and are supported in their use of the data. But the nonprofit is a partner in developing funds for scientific research, maybe research into some edge use cases that federal agencies wouldn't necessarily put a lot of funds towards. So there's a specific role in place, I think, for the nonprofit itself, and then also it is a small part of a very large consortium, and I think that consortium will remain active and remain, part of what makes OpenET OpenET.
Hold on. Can you speak a little more to like how or what you do to change? So you mentioned a lot of times like the application of water is you're trying to predict by using these ET measurements, and that needs some correction. Can you speak a little bit more to like what kind of corrections you do to like convert from one to the other?
Oh, you mean if you're looking at ET data, trying to get to the
Applied water.
ET of applied water?
Yes.
Well, so so one of the most important variables that needs to get subtracted out, right, is the effective precipitation. So what amount of the precipitation that fell was actually used by the plants to grow and then, evaporated or transpired, and what portion of the ET is due to effective precip. And that's not an easy question to answer. I don't know how many of you have sort of studied that or had classes on that. It is a question that there's a ton of interest in right now because, now that this is available, a lot of agencies, state agencies, and local agencies are wanting to answer that question, right? Like, great, we have the ET from all sources. What's the ET of applied water? And the team is getting asked that question, in many different places. And so they're working hard to determine whether or not there can be some kind of approach that can be utilized sort of at large scales to get an effective precip estimate to go along with the ET totals that are available via OpenET. I think it's sort of to be determined, where and when that's appropriate and what types of approaches are going to be best. And I don't, there's people on the team who can answer that question on the scientific details side of it much better than I could, but that is the main, that, if you're looking for ET of applied water, usually, unless there's a more complex hydrology where there's significant, shallow subsurface groundwater availability to the plant, the main thing that you're looking to subtract out is that effective precip.
So not really other outputs of water, not really like depercolation or runoff. Those are not like major considerations.
I mean, right, those are sort of calculated by, like, that is sort of inherent in the effective precip, right? So the amount of precip that is effective in terms of getting utilized, the other part of precipitation is the part that would run off or the part that would percolate, right?
Yeah.
But so making sure it's nerve-wracking to answer that question in front of him, but hopefully I got it right.
Any questions online now in the room?
A few times, but most recently I looked at a field that I know has deficit irrigation as part of it, and I was really surprised to see that I could see a difference between
Great.
the deficit part and the other part.
Wonderful.
Yeah, I don't know, I just hope I'd love to like.
Yeah, that's great. Yeah, I mean, you're welcome to get in touch if you need any help with that. Certainly, use for academic research is one of the things that the nonprofit wants to be supportive of. We're hoping that the amount of funding that we're getting from public sources and philanthropy can help subsidize that kind of usage. It's one of the reasons we wanted it to be a nonprofit, to that question earlier, and not a commercial entity.
And once again, join me in thanking Robin.
It looked like one hand was up, but I don't know.
Oh,
So,
one hand.
there a question in the,
Oh, there's one. Sharon, I think you need to unmute.
Yeah, Robin, you may have answered this, but maybe you can elaborate.
Yes, Sharon.
You can hear me?
Sharon, we're not hearing you. I wonder if you could type it.
Oh, okay.
Oh, you
can
can
hear?
hear?
Okay.
Can you hear now?
It's funny.
Okay, go ahead.
Okay, can you hear me now?
Yes.
Yes.
Okay, so Robin, you might have touched on this, but maybe you could elaborate on how maybe the GSAs, they might have used OpenET to estimate, water consumption, water needs in their area. But do you expect them to be sort of, using it, you know, as they implement their GSPs to see what kind of reductions they might be getting. I don't know, anything you want to elaborate on that?
Can you all hear me?
Yes.
Okay. Yeah, so their GSAs across the board are almost not all universally, but a lot of them are using satellite-based ET data in both the determination of their sort of baseline budget and setting allocations, and then also, Sharon, to your question, tracking use, consumptive use over time and planning to utilize that data in their annual reports and sort of every 5-year reports to the Department of Water Resources. There are sort of varying degrees to which data is being used directly from OpenET versus other sources. A lot of the connection that we at OpenET have to that particular application is through the consulting firms that are working directly for the Groundwater Sustainability Agency. So example, David's Engineering, which is a local firm here in Davis, they have access to the API and they're incorporating OpenET data and a lot of the plans that they're helping to write and helping to submit on behalf of some of their GSA clients. So I hope that was a helpful answer.
Yeah, thank you. I can see how they would
Anybody here
use
that
it.
wants to reach out and ask me something else later, please feel free to do so.
Thank you once again.